My name is Abhiman Tiwari. I'm a product manager on Azure SQL team, primarily focused on developer experience with Azure SQL DB. Today, we'll talk about T-SQL for cloud native developers. So in today's talk, we'll look at JSON capability in Azure SQL database. We'll learn about JSON functions and operators, and we'll also explore about the newly added regular expressions, commonly referred as regex, feature in Azure SQL DB. Let's understand why JSON. If you are building a cloud native application using a microservice architecture, the communication between services is typically done over REST API or could be GraphQL or could be other protocol like gRPC or SOAP or anything else. But the most popular and common data exchange format is JSON. So if two services or applications talking to each other, it's very likely that they would exchange data in JSON format. And here is a simple application architecture, what you see on the screen. If you are a developer building mobile application or web or SPA or could be Jamstack application, in any of the technologies including C#, Python, Java, JavaScript, you name it. It could be the JavaScript frameworks like React, Angular, Next.js, Vue, and so on. You can choose Azure SQL database as your backend. At the same time, take advantage of Azure SQL database security, performance, high availability, and other great capabilities. And JSON support is available in SQL Server 2016 onwards, also on Azure SQL database, Azure SQL Managed Instance, and in all the offerings. Before we introduce the native JSON data type, the JSON document could be stored in character columns like varchar and nvarchar. But now they are natively supported. So we have a native JSON type. And you can interact with the JSON using the functions and the operators, what we have. Using those functions and operators, you can transform JSON to relational data and vice versa. JSON documents is stored in binary format uh, with the introduction of new JSON native data type, which is optimized for querying and searching JSON document. Once it is passed, you don't need to pass it again. You can modify any particular tag or value. That way, you do not need to update the whole document at any point of time. And you can look at the limitations uh, compared to other services or the competitions. So with that, let's look at the quick demo. Here in this demo, we have a JSON document. We will use the isJSON function and the JSON path exist function to validate if it's a valid document and also to check if it's a valid array. And at the same point, as you can see in the second query, we'll see if a particular object or value present in the JSON document. So here I'm looking for the order number. And in the second column, I'm looking for the order date, which actually doesn't exist in the JSON documents. So this should return as a false. We have a date, but we don't have order date. So let's go ahead and run this. And as expected, it's a valid JSON document. It's a valid JSON array. Yeah, and we have order number in the document, but we don't have order date. And you can just verify that in the JSON document, which we are using here. Now let's look at the native JSON type. So here, I'll be using the JSON type to create an orders table. The column order info will be of JSON type. And I'm inserting JSON documents into this column. So let's go ahead and run this. And as you can see in the result, these two JSON data inserted into the table like any other JSON document. And you can validate the account numbers here with the data which we inserted. Here in the third scenario, I'm using query property of JSON document to generate a relational result sets. So we have data stored in the JSON format. Now I'm using JSON value function to fetch those values from the JSON document and casting it to certain type and then performing arithmetic operations. Like any other data in the relational table, you can play around with the JSON data as well with the help of the functions. Okay, now we'll look at the uh, JSON value and aggregate constructors. So here in this example, I'm creating a count table and inserting couple of regular relational records here. So as expected, uh, these records are inserted in the table. In the second scenario, and which is scenario 4, I'm creating another order table. And in this example, I have a JSON document which is stored in a JSON variable. And with the help of OpenJSON function, I'm reading the JSON document and inserting those data into a normal relational data format. So in the previous example you saw, I could, as it is, store the JSON document. And in this example, we are able to break those JSON document into relational format and we can insert in the table. And here, with the help of uh, JSON object and JSON array, we can uh, create any JSON document of any arbitrary shape and format, and also we can aggregate with the help of JSON array aggregate and JSON object aggregate. So here, if you take a look, I'm using JSON object and JSON array to generate the JSON document and the JSON array. And if you see, the phone numbers are here generated in form of array in this JSON document. Similarly, in the next example, I'm using JSON object aggregate, and all those JSON documents will be aggregated into a single document, and then it can produce a single document uh, for the number of records you want to generate for. Similarly, in the next one, I'm using JSON array aggregate with a JSON array constructor to aggregate the data. Yeah. So as you can see, uh, we can we can play around with the JSON document. We can store in a relational format. We can break them into relational format, from relational format to JSON, JSON to relational format. With that, if you want to learn more about the especially preview features of JSON, native type and couple of JSON aggregates, uh, like JSON object aggregate and array aggregate, you can just go to this link aka.ms/JSON preview. You can sign up here. Also on this blog, there are further details you can go through and learn more about it. With that, let's move on to the next topic, that is regular expressions support in Azure SQL DB. We are happy to introduce the regular expression support in Azure SQL database. Regex is a powerful tool for pattern matching and data extraction. It can be used in databases to perform complex searches, validate data, ensuring that it meets the specific formatting or content requirements, and manipulate text. Some advantages of using regex in databases includes flexibility. It allows for complex pattern matching, making it possible to search for and extract data that meets a specific criteria. It is efficient. We can use regex to perform complex searches and data manipulation operations in a single step, reducing the need for multiple queries or a script. It improves the data validation and cleaner code. And again, you can use regex to transform and standardize your data. Uh, Conventionally, SQL aligns with the ANSI standard, but our regex implementation follows POSIX standard because POSIX is more uh, more widely supported, widely used, uh, and it's the standard across in terms of front end and back end. You name it any library, majority of them follow the POSIX standard. So we wanted to align with that. And our implementation support case sensitivity, character classes, quantifiers, anchors, and the subgroups. So the native support for regex in Azure SQL DB will enable customers to write more complex search pattern and perform string manipulations efficiently. This feature is available across all the tiers of Azure SQL DB in private preview. And these are the functions we have introduced as part of our regex announcement. You can use regexp like to filter the rows based on regex condition and also to apply check constraint to ensure the data fulfills the specified criteria before they get inserted into the table. And again, you can use regexp count uh, to count the occurrences of pattern within the string. If you want to find the position of the match in the string based on your regex pattern, you can use regexp instr. Again, to replace something based on the regex pattern, you can use regexp replace for that. And to find a portion of a string from the larger string based on your regex pattern, you can use regexp subst. So with that, let's look at the quick demo. So here in this example, I'm creating an employee table and inserting a couple of records. And as you can take a look at the data, I'm inserting a couple of invalid email addresses. And also, if you take a closer look at the phone number, they're not in the consistent format. So let's go ahead and create the table. It's created. And as we can see, the 5 records are inserted. Now we will use the regex functions to filter out the invalid records and we'll fetch the valid record based on our needs. So here I'm using regexp like to filter the valid email addresses which are ending with the .com. So let's go ahead and run this. This will return the email addresses which are valid and also ends with the .com. So there are 2 email addresses which are valid, ends with the .com. There is another one, but that's not a valid email address. As you can see, the second one ends with the com, but that's not .com, that's @com. It's not valid. Okay, now I want to count the number of valid emails in my table or database. I can again do that with the help of regexp count. It will return all the valid email addresses count. So far we have 3 valid email addresses in our table. So it's returning 3 here. Now again, if I have a similar requirement that I want to count the number of valid email addresses based on their domain, that again we can do that with the help of regexp substring here. So this will return me the count. We have 1 email addresses with the contoso.co.in and 2 with the contoso.com. Now in the next example, let's say I don't want such records to be inserted in the database in the first place. So I can again use the same regexp like function to put the check constraint on the couple of columns on the email and the phone number to make sure that the data getting inserted should meet this pattern. So let's go ahead and recreate the employee table with the check constraint. So as you can see, the data is in right format now. So to validate if the check constraint is working, we'll go ahead and try to insert incorrect data here, and it should complain. Yeah, as expected, it's complaining about the check constraint and the email address because email address is not in the right format. We'll go ahead and fix it. And now, ideally, this should complain about the phone number because that's not in right format. It should be hyphen. We are using underscore there. Yep. So it's complaining about the phone number here. Let's go ahead and fix this as well. And this should go in. Yep. So as expected, this record is also inserted. Let's go ahead and look at the table. And yes, we could see successfully we have inserted the demo data in the table. Now, if we want to find the position of the match uh, in our query, we can use the regexp instr. And here in this example, I'm trying to find the position of @ in the employee email addresses. And you can look at the result set here. We could successfully find the position of the match. You can again validate that. And in the next example, I am trying to replace the format of the phone number. Uh, Previously, it is in the 3-digit hyphen, 3-digit hyphen, 4 digits. Now I am asking it to put the initial 3-digit in the bracket and leave the remaining uh, 3-digit hyphen, 4-digit as it is. And in the second column, I'm trying to mask the last 4 digit of the phone number. So let's go ahead and run this. And as you can see, the first column has the original format. In the second column, I could change the first 3-digit in a bracket. And in the third column, I could mask the last 4 digits. And again, with the help of regexp substring, we can find the substring from a larger string. So we will find here in this example the domain of each email addresses. And as you can see, uh, we could successfully fetch the domains of each and every email addresses. Yeah. So if you want to experience the latest feature before anyone else does, and see how regex is integrated in the Azure SQL DB and provide your feedback to save the future development, just head over to aka.ms/regex-preview-signup, or alternatively, you can scan the QR code. You can submit your sign up request. Our team will validate and onboard you. And these are the reference links for the JSON and for the regex, and also for the entire SQL dev blogs. The last one, you can uh, go through those blogs to learn more about it. You can start your learning journey today. To dive deeper into .NET and Azure with our curated learning collections, you can just head over to the link. Again, to take the Cloud Skill Challenge, you can go through the second link here. And to download .NET 8, to get the latest version of .NET and explore its new feature and improved performance, you can just head over to get.net/8 and you can download it. Again, for the migration tools, you can go to aka.ms/getappcat and you can enhance your Azure migration with the new tool. With that, we have reached the end of the session. Thank you. Thank you for joining today.